Okay, so let's talk about topic 4, data and databases overview. Some of the things we're going to be discussing here are the differences between data, information, and knowledge, um, how we define the term database and identify the steps for creating one, describe the role of database management systems, describe the characteristics of a data warehouse, um, as well as data mining and some of the organizational benefits to be derived from the implementation of one. So here at the beginning, there's a couple things you might want to take a look at. Some information between, some additional backgrounds and deeper dives into some of this information. This idea of refined knowledge, the ability to kind of get organizations to gather, transfer data into knowledge that can be leveraged for benefit. It's a good discussion here around the difference between data, information, and knowledge, and some definitional stuff around what is information. So data overview. So there's the overview. So some of the terminology that we look at when we're talking about data. There's really there's like 4 tiers, and you can think of this as like a pyramid. So at the lowest level of the pyramid, we have data, which is really defined as being a collection of facts. So we are awash in data. Data has basically, it's a collection of facts without necessarily any context, but just basically could be measurements, can be bits of information, could be anything really. So we describe it as a collection of facts. The trend has been larger and larger amounts of data has been generated because we have the ability to do that. The introduction of things like personal computing, and then the kind of move to mobile computing, and mobile computing, i.e. cell phones or smartphones, really have driven volumes upon volumes upon volumes of data. So next level up in our pyramid, we talk about information. So information is a presentation of facts in an organized manner. So basically, you take data and you apply context to it, and that provides information. A large portion of what organizations will do is spend a lot of effort gathering data, and they're basically transforming their data into information. So data is smaller. The volume of data is always going to be larger than the amount of information. So information, the transformation really kind of involves a reduction in size, concentration, consolidation of data to create information. Knowledge is the next tier up. So it's the use of information to make informed decisions. So it's really kind of taking this context and then applying additional information, into particular situations or scenarios which involve the application of the information to establish results. So in effect, what you've got is information is refined, or knowledge is refined information. Not all information is knowledge, but all knowledge is derived from information. And then at the top of the pyramid is we have wisdom. So this wisdom is, once again, this is a smaller percentage of either data or information or knowledge. It combines knowledge and experience to produce deeper understanding. One of the challenges is not that we don't not lack for data. We don't actually lack for information. As a matter of fact, the risk we run is information overload. So the ability to have more information that can be that is needed, or to be able to differentiate the priorities of information, the ability to hold multiple facts in your head at the same time becomes very challenging for folks, in particularly in trying to deal with, I guess, in modern decision making. So it's something that has been out there, but it has really come to the fore now, especially as we see more and more and more information, data, and information being generated. The difference between qualitative and quantitative. So really, quantitative data is really things that are measurements, so usually numeric. So things like counts, averages, results of mathematical calculation, individual operations that can be expressed as some sort of numeric value. That is what we mean by quantitative value. Um, qualitative data, qualitative data is more representative of characteristics, so descriptive characteristics, and things that could be put into categories. So there's a difference, there's a clear difference between the two. One is mathematical, one is more descriptive. But both exist, so it's not a matter of, well, what's more important than the other. Both have their own purpose. Each one is part of is a type of data which we'll see out there and which we process this is part of information processing. We talk in terms of a database. So the formal definition of a database is an organized collection of related information. So what we think of as most modern databases is what we call relational database. And a relational database is represented as a set of tables which has a set of fields in them, right? And the fields are represented as columns of data, and the records are the rows within the table. So if you think of a two-dimensional table with X number of columns and X number of rows, from a columns perspective, usually you can go up to, I think, something in the vicinity of 256 columns, but most databases are much smaller than that. Rows can be measured in millions. All right, so what will happen is, the collection, the volume of data is usually represented in the rows, not necessarily in the columns. The columns are more specific types of data. All right, and what happens is the idea is that everything that's in a column is of a particular type. So if you say a column is an address, then everything you find in that column is an address. The other characteristics of a table that you need to understand is that there is what is called a primary key. So what a primary key is simply a field that makes each record unique. All right, so that in relational databases, every row in a column has to be unique, and the thing that makes it unique is the primary key. Primary key can be one field, it could be many, many fields. There's no restriction on that. It's really a matter of making sure that it is unique. Database design, we talk around the requirements analysis of a database. So databases are based around the fundamental thing to think about with databases. There are rules. And in order to establish these rules, there is a design process. So the first part is the requirements: who, what, when, where, why. Is really usually a first step, and usually is kind of a process by which, from a design perspective, description is developed of a particular situation, as it were, and then information is gathered around that and structured. So what happens is the information is gathered and then is really structured into tables. So the unique identifier that doesn't change is it becomes a primary key. And then, for example, usually best maybe to look at this in terms of an example, an order. Basically, if you were to categorize an event such as you going into a store to buy something, there are certain things that are established with it as part of that event. So you would have things like the location you went to, the time you went there, what door you went through, things of that nature. So there's a bunch of characteristics that are associated with a particular item, which really becomes part of that, which become part of the table. All right, and then what happens is you have relationships between tables. That's the name. That's the name of relational databases, is that the tables are actually mathematically described as relations, and they have, each table has a relationship between other tables. All right. So the idea is that what will happen is a primary key, the way tables are linked together is that the primary key from one table can be set up as a column, and the other one, which will actually give you the ability to query or be able to do searches. This concept of normalization. So normalization, once again, is part of the database design. It's really the idea of eliminating redundancy of the table, of data between tables. It's done for a couple of reasons. Number one is for efficiency, And number two, it's also making sure that that the information can be recovered, that is recovered is accurate. One of the things about a database is the way a database design should be set up so that when you do a query against it, the results you get back are correct. So that is enforced by the rules. All right, so you can do a lot of, you can structure it a lot, there's any number of ways you can set these things up. There's no one set pattern in which you do it. But what will happen is one of the big emphases is things like you want to eliminate duplicate items because, say, for example, if you have a date, a particular date that would appear in multiple columns across multiple databases, the question becomes, okay, which one's the real date? So you really want to make sure that information is designed, that the information, the data that's stored in the table has a unique, or, can be described as being correct and unique. So the process with normalization, they call things like normal forms. So first normal form, second normal form, third, fourth, and fifth. Most databases, most production relational databases that we see that are out there right now, usually are somewhere between third and fourth normal form. All right. Usually, you want to get beyond first and second. Third becomes where you get things are normalized to the point where you can do most stuff. Some people are, have a little bit more emphasis and then push forward to fourth. Fifth is maybe not as common, you see. So usually it's third and fourth normal form of designs will fall into one of those two categories. So we talk about rules, we talk about data types. So a data type is the rule of what goes into a field. All right, so there's a couple characteristics. A field should have a length, basically what the maximum length is, how long should a field be. If a field should have only numbers, it should be defined as numeric. If a field would be defined as characteristics, it would be alphanumeric because you could either have a letter or a number in it. A field could be defined as only having dates times, or currency. So each one of these fields, a column can only have a certain type of data in it. All right, and that's all part and parcel of the design. So what will happen is when you do a query, what you'll get back, what the rules will be, what you should get back when you execute a query. The other thing that's interesting about it is that if you try to insert something into that field, like for example, you define a field as a date and you try to put alphanumeric characters into a date, it'll reject it. And part of the reason is it makes sure that everything is going to be, if you define something as having a characteristic, it must have that characteristic. Right? If it doesn't have it, then you will run into problems. An object is just simply a different type of data. Basically, it could be things like a movie, it could be an object, or video, or sound, or things like that, or just a different type of data that can be stored. Most modern relational databases will have the ability to store things like that in that fashion. So we talk about metadata. Metadata is data about the data. So basically, we talk about the rules. It describes the rules of what a table should look like, what the rows are, what the characteristics of the rows are. So it's descriptive. So a couple of features. It's designed to be descriptive, so it describes the information and resources. It can be structural, so it defines basically what the structure of it is. And then it's administrative, the ability to define and provide access to a database. One of the characteristics we want to make sure we have in a database is not everybody can get access to it. So, creating a database with everybody's social security number and then leaving it available for anybody to get to it is not a good practice. And so security in databases is also part of the database design. Getting data out of a database requires something called structured query language, or SQL. You might have heard of this term before. You see SQL or SQL queries. And what it is, it's a language to analyze and manipulate a database, a relational database. There are commands that will let you create a table, so create, alter, dot, it'll define the data. You have data manipulation language, which is the ability to either get data out of a table or to insert data into a table or update data in a table or delete data out of a table. What we call transaction control language is a technique. Basically, it's a mechanism by which updates to the table can be managed and locked in or rolled back. What will happen is you have the capability of, with a database, you can make a change to the database, and then you can decide at the last minute some unexpected situation comes up. You have the ability to roll it back so it goes back to what the original data looked like. And finally, we have DCL, data control language, is really access to either granting or revoking access to data in a table. Okay. And if you look at the bottom here, we have this SQL tutorial. You can take a look and give you an idea of the command. SQL is a pretty extensive language. It's been around a while. It's very extensive. It is used, basically every company has relational databases. People who are familiar with developing and using queries. Now, a database management is what we've been talking up till now is database, this concept of a database itself. A database, so that is the conceptual, the model. Basically, relational databases are based upon relational algebra, which is a form of mathematics. A database management system is actually how it's implemented on a computer. So it's really a software program. We talked in the last sections about software. So it's really a software program, and it's designed to implement a relational database. They're very complicated pieces of software. You got to be able to create, manage databases, change the structure, do analysis, be able to get data out of it. So some of the major DBMSs, some of which you may have heard of. So Oracle, which is the largest relational database manufacturer. Microsoft, which has a product called SQL Server. IBM is a product. IBM was kind of an early on implementer of databases. They have a product they call DB2. Sybase was originally a standalone company. It was acquired by SAP America a couple of years ago. And then MySQL is a pretty well-used, well-established open source relational databases. You can actually have these other ones are closed source, but MySQL is an open source database. There's actually a number of other ones that have really come up over the past couple of years. So you're seeing, the ability to have either a closed source or open source database platform. So these are the enterprise. So these are designed for large applications running organizations, military operations, things of that nature. Personal database is really the same thing. It's a relational database, but it really is designed to run on a particular, either a workstation, laptop. So the ones that we're familiar with and what we've talked about in this class is Microsoft Access, which has been around a while. Obviously, a big difference between an Oracle large-scale, multiple terabyte Oracle database and maybe a single gig Microsoft Access database, but the mechanics of how it does queries and stores data and structures and assigns tables and all of that stuff is really the same between Oracle and Microsoft Access. There's some other types of databases that have been around. Some of these things kind of predate relational. Relational has been the mainstream for about over 30 years now, but some other different types, some of these were kind of in play leading up to relational. So hierarchical, which was actually developed as part of the Apollo space program. Network is a different type of, kind of a variant of hierarchical. Object-oriented and object-relational. There was a big push around kind of supposedly moving from relational to object-oriented databases. What ended up happening, most relational database just adopted object functionality into it. All right. So it's kind of a different storage type. It's how you'd be able to run things like movies in a database, or a album of music in databases of voice or video. The one thing that is new is something called NoSQL. So really, NoSQL stands for not only SQL. So what it is, it's a it's associated with big data, and we'll talk about that just in a sec here. But basically, it does let you use SQL, but it's the way it actually stores the data is different, and it allows you to be able to implement very, very large databases, much larger than what we see traditionally with relational databases. So we have a couple of labs we're going to be doing. We're not going to be touching the Excel lab, but we are going to be doing the Access lab, and we'll be talking about that. So let's talk a little bit about information in organizations. Kind of the applicability, I'm talking about knowledge and knowledge management. How is information and knowledge used in organizations? So there's a link here to what is knowledge management, and I recommend you take a look at that. But the essence of information is, ultimately, all organizations are concerned about one thing: making decisions. All right, and to make a good decision, what you want to do is you want to make an informed decision. So the question is, any organization of any type really needs to do. You need to understand what the type of decisions need to be made. When do they need to be made? And then the question is, on what basis do you make that decision? So it's a question of what information is available, and then who makes the decision. Some organizations will move very quickly and do very fast in terms of its decision-making styles. Other organizations will be much more meticulous. It really depends upon the culture and the way the organization operates. What is the risk? What is the position of risk? Within the organization, making a risky decision without having a full information, or trying to analyze everything to drive as much risk out of it. So it's really, the idea of information in organization is really kind of aligned with the organization and how the organization makes decisions and how it operates. The barriers to information, and there's a whole bunch of them. In a perfect world, you can just get whatever you need whenever you need it. The reality is, though, there's the gathering of information, the translation of data into information can be a fairly pricey proposition. Computer systems and the amount of overhead and configuration and work is very significant. If you look at, there's a reason why Oracle is as large and as successful as it is. It is basically how much money it's made over the years. It's kind of a reflection of basically how much emphasis organizations have put on information. Different organizations will have, as we said before, decision-making styles and risk-taking styles. There's other things though in information gathering. So things like the structural barriers, like who needs to know data versus who needs to know data versus how much data needs to be shared. Not all information is equal. So there are some things that you need to have everybody to know, and some things you don't want to have everybody know. The same thing is, there's some information you want to have shared versus not shared. All right. So once again, that depends upon, it's very situation specific. Organizational barriers, culture, policies, and rules. Different organizations, especially as organizations get larger, what you see is, as it becomes more and more diverse and decision making becomes more distributed through an organization, the ability to kind of gather the right information at the right time to make a decision becomes much more challenging. Sometimes information that one side of an organization needs is derived from a whole other side of an organization. So kind of gathering, communicating that becomes a big issue. Cognitive overload. We talked about this a little before. Basically, the amount of information people can hold in their heads at any given point in time. That is a real factor in the ability to make decisions, because sometimes you get too much information. And trying to get the right amount to make the right decision at the right time is a challenge. And then finally, this idea of IT frustration. One of the big historically, one of the big challenges in information systems is that basically the systems never do what you want it to do when you want it to do it. So there's always been a challenge around trying to get information faster and faster and faster and faster. The problem is, though, we've actually we've made progress in getting information out faster and faster. The problem is being able to deal with that as we go. So the kind of you kind of shift from one end of IT frustration when you can't get enough information to cognitive overload where you got all the information you want, but you have a difficult time dealing with it. So there's a theory, UDM. So UDM, Unified Data Management, is a theoretical model, or it's defined here as a best practice for coordinating diverse data management disciplines. So the idea is it's a methodology that is being put forth really to describe how organizations should deal with coordinating different data management within an organization. Much easier said than done. So this is kind of an aspirational vision. Some organizations have made progress on it, but quite frankly, not every organization. Most organizations will acknowledge that getting all of the information and getting it under control and having it basically at your fingertips is something it's still something they struggle with and have to work very, very hard at. It becomes very expensive. Organizations that are successful are organizations that have, a lot of times organizations that have been able to do this stuff better. Well, a lot of it is reflected in their performance. So data warehouse. Data warehouse is a tool that was really developed as a means of supporting decision making. All right. So it's, if we looked at the applications we talked around in the last section around ERP applications, which are very good at gathering information, but not necessarily good at reporting information. So data warehouses is really another specific type of computer platform, which is specifically designed to extract information from operational systems like ERP or CRM and put it into a common repository for storage and analysis. So the idea is you take all this information, you kind of gather it together, and you structure it in such a way so you'll be able to extract it and get information and be able to identify stuff. So it's really specifically designed around this. This is kind of if you look at kind of if you look at an ERP system as kind of focused on this data to information, kind of the first level of this. This becomes kind of a data warehouse, kind of focused on this ability to take all of that information and transfer it into knowledge, start creating more of a knowledge. All right. So a lot of different designs, a lot of different. It's been around probably about like 25 years. So things that we have one data. You can have one large data warehouse or one data warehouse actually being able to break up into smaller, what we call data marts, that are specific business problems. Specific problems from an overall warehouse. What will happen though is, the basic things are you extract the data. So you will take data from a existing application system, an ERP system, through an extraction. So you take your non-operational data through extraction. You then will translate that into basically into what we call a cube. So what will actually happen is we're a relational database is a bunch of tables. What will happen for data warehouses is we'll take those tables and convert them into what they call a cube, which is built around, we call time variant. All right. And then it's transformation, so standardized through transformation. But the actual terminology that gets used in data warehouse world is ETL, which is extract, transform, load. So you're taking the data from a relational database system to get into something that you can do reporting on. Benefits, the ability to really deal with organizational data and be able to see it in different ways, be able to do different perspectives on it. You can combine disparate data, you can centralize data, you can develop, statistics basically and reporting in a fashion that is really difficult to do with an enterprise application system. Enterprise application systems are good at doing execution and operation, but not necessarily good for doing analytics. So you'd be able to go back and do trend analysis and snapshots of data and be able to get a perspective how different things are happening, maybe behind the scenes, as opposed to a relational database, a operational system which is focused on just simply the execution We talk about knowledge management. So knowledge management has been around a couple of years now. It's actually a big area. The ability to actually use information to make informed decisions is the formal definition of it. Formalizing the capture, indexing. So there's applications that are specifically designed to do this. So the idea is organizations are really trying to develop a competitive advantage of using this stuff and trying to extract information from experiences from an organizational perspective, from the people's experiences. One of the biggest challenges is within this is, quite frankly, the fact that people, basically are the people who kind of who are doing the work are usually the ones who kind of hold the knowledge. And trying to transfer what is in their heads into a computerized system is not an easy task. So there's a lot of systems out there. There's a lot of money being invested in these things, but sometimes you may or may not get the benefit that they want, because usually you can't necessarily always replace people with systems. All right. And then finally, when we talk around knowledge management, ultimately being able to derive wisdom, the ability of combining experience and knowledge to produce deeper understanding. This is an ongoing area. This is where we start getting to things like machine learning and kind of more sophisticated analysis, which is kind of coming into bear. But ultimately, the human side of this stuff cannot be eliminated. So I think it's one of the things that, is for all the effort that goes into it, that's still a challenge, and will probably, for some period of time, will remain a challenge. So big data. So the definition of big data is something it's data that is so big a relational database can't hold it. All right, so data sets with size or complexity beyond the ability of commonly used software to deal with. But basically, it's so big it breaks a relational database, or it is difficult to deal with using a relational database model. There's 5 V's within a big data. So it's variety, the things that make. Why does data get big? Well, there's 5 things. So the 5 things are the variety of data. So you think about where data can be generated from. You take a look at the volume of devices that it can potentially develop and generate data. Thing where terminology you might hear, something called the Internet of Things, where everything is connected onto the internet and everything is generating data. So the variety of data from all these different sources. Related to that, the volume of data. Maybe the sizes are significantly. It used to be a terabyte was a pretty large, considered a large measure of data. We used to run entire organizations on a terabyte. Now terabytes are not what they used to be. So the volume and the size, you can generate multiple terabytes of data in the course of processing over the course of a day. So that's a very, the large size of it. The velocity, how quickly it comes in, how quickly it goes out. The other 2 is, also important, the value of data. Not all data is as valuable. There's not everything is equally valuable. Some things are going to be more valuable than others. And trying to sort out, valuable information, valuable data versus not necessarily as valuable data is one of the challenges that gets faced with this. Then the veracity of data. Is the data accurate? The accuracy of data becomes paramount, because ultimately you can gather volumes and volumes and volumes of data, but if it's not trustworthy, then it doesn't really add a lot of value. So those are the 5 V's, and when we look at big data, those are the things that really have driven this move towards big data. Data mining is really a technique for kind of analyzing large data sets. Started with data, kind of as we started creating larger and larger data warehouses, the ability to kind of go in and be able to, not necessarily have structured, just like a query, just being able to pull information out, but be able to kind of analyze the data and look for different relationships within the data. So it's, it focuses on trends and patterns and associations. It's once again against large data sets, past 10 years, a lot of it was focused on data warehouses. Now we're moving that into big data. And we're getting into, the focus is going on things like hypothetical questions like what if, being able to build a model and be able to take the data, build a model and then execute against that model with different degrees of predictability, probability. Business intelligence, basically process available data, targeting competitive advantage. That has been, business intelligence and analytics have been aligned with data warehouses. It's all part and parcel of the kind of what's been happening in organizations as they try to get their arms around, kind of tackling this information data beast. The idea is, ideally, if you can, you know, understand, by going through business intelligence and analytics, understanding what's happening inside of any other organization or how customers um, are behaving or kind of what's going on. If you look at organizations like Amazon, Amazon will evaluate every click you put onto a screen. It knows everything you've done through every, you think about how many people are onto Amazon. And they take that information, go back and they can analyze it and, be able to find and identify trends. That's why you will, when you get into Amazon, you'll get a, you know, recommendations. Maybe you want to buy this or maybe you want to buy that because they've analyzed what you've done and kind of how, kind of what your behaviors are when you log in and you're poking around out there. One of the biggest things in dealing with this, one of the interesting byproducts, is privacy concerns. I mean, you can do some very interesting things with data, and some people call it spying, some people call it customized marketing. One person's customized marketing is also one person's spying. So the amount of data that's out there and the ability to do stuff with it really kind of has risen a whole bunch of new concerns. A lot of what people are starting to understand is, when you click that thing at the beginning of when you set up an account on Twitter or on Facebook, there's a lot of information you've given away, and a lot of information which actually can be very valuable. So I think this is still a story being written, being able to who really owns that data, and what do how should that be either monitored or controlled, or whatever. Who should be the responsible parties dealing with this? Right. So this is an open question, something that's still going on even as we speak. Right. So here's our study questions. Something you want to take a look at. I think we had talked about these in class. And then some of the information, basically the reflection question. And that's about it.